Just see this question. This question came in GATE 2009. Okay. So I read it for you. The enter underscore CS, it's a function. Okay. There are two functions, enter underscore CS and leave underscore CS. To implement the critical section, CS means what? Critical section of a process are realized using test and set instruction. Actually, it's a test and set instruction fragment code is given, even though the test and set instructions definition is not given everywhere. So you are expected to know about the definition of test and set instruction. Actually, you see, you don't have to memorize the code. You have to understand the things. What happens in test and set instruction? What happens in swap instructions? Okay, what happens is in lock variables. You have to understand the things, because in the examination they may change the code. Okay, there will be a little bit change in the code. So it's very important to understand the codes. Okay, so here, although the definition of test and set instructions are not given, but you are expected to know how it works. Okay, so now you see, now here the code is given, void enter underscore CS. It's a enter function is there, and inside the enter function it's written while, and in the while the condition is test and set, and you see a parameter x has been passed with this test and set functions. I will explain everything. Then while leave underscore CS, x is equal to 0, and you see what they have asked. They have asked to select the correct statements. Okay, and moreover here one thing is also mentioned, that x is a memory location initialized as 0. Okay, and you see we have to select the correct options. First option is that this solution is a deadlock free solution. The second one is that this solution is a starvation free solution. Third statement is processes enter a critical section in FIFO order. FIFO means what? First in, first out order. If you have studied about the queue, then you will understand this first in, first out order. And after that, the fourth statement is no mutual exclusion is there. So let's solve this question. So here I am solving. So you see, just remember what used to happen in test and set function. In test and set function, at this point in the while loop, you see there used to a test and set function used to be called in the while loop. Okay, and here what was the parameter? ampersand lock. Okay, they used to send the parameter as the address of the lock variable. Okay, I think before watching this video, you should watch my video of test and set instruction. Then I think it will be more clear to you. Fine. So now you see here, in place of lock, they have used the term, they have used X. Okay, and what happens in test and set instruction? You see, it's an entry code for, in order for a process to enter inside the critical section. Say this dotted line is a critical section. Okay, so in order to enter here in this part, a process must go through this while loop. Okay, if a process is stuck in the while loop, then while loop has to be broken. Okay, so suppose there are two processes, P1 and P2. P1 and P2 are the two processes. If P1 wants to enter into this critical section, then P1 has to go through this while loop. Okay, so now you see, yes, X has been initialized as 0. So you see here it's written X has been initialized as 0. So X is 0. Fine. So void enter. So void enter underscore C is 0. So now this while loop will execute. While test and set, 0 has been passed as a parameter. Okay. The address of X actually has been passed as a parameter. That is 100. So what test and set function will do? Test and set function, what it actually does? It returns the old value of the lock. Here x is the lock. Okay, it returns old value of the lock, and after that it sets new value. So here what will happen, you see, here the old value is x because x is initialized as 0. So here the old value is 0 because x is initialized as 0. So when test and set function will be called, so test and set function will return 0 here. Old value of x will be returned. So this code will receive 0. While 0, it means what? While loop will be broken, and after that the process will enter inside the critical section here. Fine. And after that what will happen? And I have also told you that after returning the old value, a new value will be set for x. So after, if 0 is returned here, after this in the test and set function, x is again initialized as 1. Why? Because after the process enters here, the value of x becomes 1. The value of x becomes 1. It means what? Here, if the value of x is 1, then another process will not enter inside the while loop, because the condition will remain true and the process will stuck in this while loop. Okay. So that's about test and set instruction. I think you should completely watch my previous video. Here I've explained everything in the shortcut way. Okay. So let's solve this question here. So the first option is deadlock free. Okay. So let's talk about it later. Second option is starvation free. So test and set is starvation free. You just think. Okay, I tell you. So you just remember from my previous lecture of test and set instruction that there is a bounded waiting problem. Okay, actually there is no bounded waiting in test and set instruction. So if there is no bounded waiting, it means what? There may be some process which may wait infinitely. Okay, so it's better I will explain you here. If there is an infinite waiting, then there is a starvation. So let's see how there is an infinite waiting. You see here. Here you see, let's give me the line number 1, 2, this line number is 3, this while loop is third statement, okay. Then this bracket is fourth one, then this one is 5, 6, this is 7, this is 8, okay. Suppose P1 wants to enter. So I am explaining whether it is starvation free or not. So P1 will execute the line number 1, okay, P1 dot 1. P1 will execute line number 1, and in line number 1 we have x is equal to 0, okay, because x is initialized as 0. P1 will execute line number 2, okay, it's simply a curly braces. P1 now will execute line number 3, fine. So when P1 will execute line number 3, what will happen? Of 0 will be returned here. Okay, this while loop will be broken and P1 will enter inside the critical section. So after this, what will happen? P1 will enter inside the critical section, P1.cs. It means what? P1 has entered inside the critical section. And also one thing that has happened is that after entering into the critical section, the value of x is made as 1. Now the value of x is made as 1. Fine. Okay. So now P1 is inside the critical section. So suppose now P1 wants to enter inside the P2 also wants to enter inside the critical section. So P2 now will execute line number 1. Okay. So now P2 will execute line number 2, and when P2 will execute line number 2, you see the value of x is equal to 1. And now the test and set instruction, you see here test and set instruction has been called. So the definition of test and set instruction will return the old value of x. Now the old value of x is 1. So 1 will be returned here, and now P2 will stuck here. Okay. So P2 is stuck in line number 3, sorry. In line number 3, while loop. Okay. So because the value of x is 1. So now suppose P1 executed line number 5. Okay. P1 executed line number 5, that is exit section, and after that P1 will execute line number 6 and 7. So let's write P1 executed line number 7. Okay. So what will happen? The value of x has become 0, and since the value of x has become 0, so what will happen? Process P2 here is stuck in the loop. So this while loop will be broken, and it is also possible that this while loop is broken before process P2 could enter inside the critical section. Another process will come from somewhere else, P3. Okay, and P3 will get the entry inside the critical section. I mean to say that P3 will execute line number 1, P3 will execute line number 2, and ultimately P3, since both these processes, let's suppose that after P2, when P2 was stuck in the while loop, after P2, P3 also tried. P3 came after P2. P3 also tried, and P2 was also stuck in the while loop. Okay, but when P1 came from, P1 came out from the critical section after executing this line number 7, then the value of x became 0. So this led to the breaking of this while loop. So before P2 could enter into the critical section, P3 entered inside the critical section. So you see here, P2 came earlier than P3. Still P3 entered inside the critical section and P2 could not. Now P2 will again have to wait. Fine. And suppose now P2 is waiting. Okay. Now another process came. P4 executed line number 1, P4 executed line number 2, P4 executed line number 2, and since you see P3 has entered the critical section. Okay, how P3 has entered the critical section? After breaking this while loop. So how this while loop got broken? Because the test and set instruction, here the test and set function has sent the old value of x, that is 0. That's why this loop got broken, and when P3 entered inside this critical section, again the value of x became 1, so that when P3 is here, other process should not come. So now P3 is in the critical section. After this, P4 is trying to enter, P4.1, P4.2, and now P4 will execute this line number 3, and now P4 is also stuck in the while loop. So now you see process P2 and P4 both are stuck in the while loop. Okay. Now suppose process P3 came out from the critical section and process P3 executed this line number 7. So here I am writing process P3.7. So the value of x again became 0 here. Since the value of x became 0, so here it means what? While test and set, 0 is passed to the test and set function. So the test and set function will return 0 here. So when the 0 is returned here, this while loop will be broken. So if this while loop is broken, then P2 should enter inside the critical section. But it is possible that before P2 could enter inside the critical section, P4 will enter. P4 will enter inside the critical section, P4.cs. So see here what's happening. Here P2 keep on waiting, and other processes which came after P2, they are getting the chance. But P2, it came very early, still P2 is waiting to enter inside the critical section. So you tell me, is it starvation free? So first you tell me, is there any bounded waiting? No, there is no bounded waiting, because there is no there is no limit on the wait for each process. So there is no bounded waiting. Here you see P2 is waiting infinitely. So is it starvation free? Of course not. There is starvation. You see, in this example, P2 is starving. So this statement is incorrect. This is false statement. Okay, because there is starvation. Process enters the critical section in first out order. Is it really happening here? You see, no, because you see here, process P2 came earlier than process P3 and process P4, despite process P3 and process P4 got entry before process P2. So there is no first out order. According to the first out order, if P4 is if P4 is coming first, then P4 will come out from the critical section. After that P2 will get the chance to enter the critical section. After that P3 will get the chance. After that P4 will get the chance. But here what's happening? Here P3 and P4 came after P2, and P3 and P4 entered the critical section, and still P2 is waiting. Okay, so there is no first out order. So this statement is also false. Fine. And here it's written no mutual exclusion. Now, there is a mutual exclusion. As you already know, that in test and set instruction, there is always a mutual exclusion. So this statement is also false. Deadlock free. Yes, this is a deadlock free instruction. There is no deadlock in test and set instruction. Rather, there is a spin lock. Okay, due to busy waiting. So it is deadlock free. It's a correct statement. Fine. So I hope you got it. Thank you.